Good afternoon, guys. And today our topic is particle swarm optimization, or you can say this is a swarm optimization. So, first of all, we have to write. So, this is particle swarm optimization, or you can say this is swarm optimization. It is motivated from the bird's flock, or the flocking of birds, or the schooling of fish. Whenever some birds are flying, they are unidirectional, they are flying in unidirectional flying, and whenever they don't know where their food is there, where the food is there, they are going to flying. But you have seen their manner is a unidirectional. Your manner is their flocking of birds is a unidirectional, but food is here. Say food is here, they don't know where is the food, but they are updating their position one by one position. So one unidirection, whenever say these birds can watch, can and identify this food, yes, this is food, then and then it's change its position. The next position, the birds, this is red colored birds. I'm giving you this red color birds just coming, change its position, and other birds are just following this. Other birds are just following this. This is one, this is two, this is three, this is four, this is five. Say this is four birds can identify this is food, and it is change its position so that it can go. Look, it's just change its position. This position is three, this position is two, it's also changed, but they don't know what happens. This is two. Say one number bars is till now. This is at the back side, and this is five bars. One. This is one, two, three, four, five. Five number bars are there. So in this way, they are following the best path, best bird, or best fittest position. And after some time, this bird reach to this food, and by following this number four birds, other birds can also reach to this food position. Okay, in this way, they are reaching to the food. So what are the logic behind their flocking or the swarm of schooling? First of all, uh, good afternoon to all of you, and happy new year to all of you. Uh, so in this way, they are getting this food. So first of all, there are two positions is there. First position is called local based position, and second one is called global global based position. So first of all, we have to know what are the local based position and the global based. Look, in this position, whenever this is the T1 time, this is the T2 time. So in this position, they all know that after some position, it will go into the this position. So this is the local based position. Okay, they just change their position. But whenever they reached there, this is the global based position. Okay, in this position, you can see these four number bars are now leading. Sometimes this beast is called local leader, and the global leader. Okay, so in this way, they are changing their velocity, they are changing their position, and ultimately they reach their position. So these things are adopted for the swarm optimization. And why this is swarm optimization is called particle optimization, because whenever we apply this, then each birds or each fish are treated as a particle. That's why this is called particle swarm optimization. It is also called PSO in short form. Okay. So these bio-inspired phenomenon are taken mainly two things. First, from flocking of birds or schooling of fish. In your aquarium, if you put same variety of fish, you can see whenever their bubbles are going on, and fishes are just going to here and after few times they just change this position. Then this fish number one, fish number two, fish number three, fish number four, fish number five, and say this is fish number six. After some times, whenever they come here, and after whenever this fish reach to the bubbles, just change its position. Then it change its position just like this. If you watch this, you can understand this thing. Just fish number one just change his position, just one bubbles are there. This fish number two, this is five, this is three. They are changing their position. This is four, and six number fish are there. So they are moving in this direction. They know uh, here is the end of this aquarium. Then they starts moving and just change its position. So again it is following the number of six, and again this is they are playing just like this. This is called schooling of fish. Means we don't make them teach what we have to know, what we have to do, but they are internally internally learn themselves, so that they are again searching for another position. So in this way they are doing schooling. This is called schooling of fish, and this particle swarm optimization are taken from their logic. The logic is that first is artificial life, that is mimicking bird flocking and this fish schooling, and swarming of uh, swarming theory. They are going in the swarm in lots of quantity they are doing. Okay. In your discovery channel, they are making fish swarm of fish are making a big figure so that the other prey fish couldn't attack them. Okay, so this is their logic. They change their position, and they follow the global position. Means in which position they occupied, so that it can reach their food, or they make some shape. This is called the global. And after some time, they are changing their position, local position. So there is a two position. So this is basic about this particle swarm optimization. Now we will go for the first introductory part. Who innovated this? PSO is, just write down this, because so many questions we have to face this. PSO PSO is proposed by scientist Everhart and Kennedy. Everhart and Kennedy in 1995. Okay. They propose that this is their actual statement: a new optimizer using particle swarm theory. Okay, this is Averhart and Kennedy in 1995. They proposed this new optimization theory. This was a proceedings, means this was a journal proceedings, uh, and it was it was come in Japan. It was published in Japan. A new optimizer using particle swarm theory. It was their journal paper, or you may say this is their proceedings. Okay, and in these proceedings they stated this swarm optimization. Okay, in 1995. So what is this? This is a direct search method. This is a direct search method. Okay, and PSO developed PSO is developed, sorry, using first one is first one is artificial life. So what is this artificial life? Artificial life is just mimicking the swarm of mimicking the swarming of schooling of the fish and flocking of the birds. And swarming theory. Second, second is evolutionary computation. Means they are mimicking the artificial life and evolutionary computation. These two are the basic components of this base of the PSO. Okay. So how it is working? First, this is flocking of bird. This is flocking of bird. So this is one. This is two. After some iteration process, they reach to this food. In here, they are changing their position. Say this is one, this is two. They are changing their position. Say this is this time of one, this time it is coming over here. This is one, this is two. Sometimes this two is there, but one is there. So they are continuously they are changing their position. This is called the local base position. And whenever they reach, which birds reach to this position, this is called global base position. How this is reached? Because this bird, say this is the birds, this is the birds, They don't know which position they have to achieve, but they are changing this position. Say this is one, this is two, this is three. After some time, this one want to achieve this position. So this two is here, one is here, one is here, three is here, and but you are, this is look like same, but they are changing their position. These birds want to come the first position. They are, look, this one number birds are at the last position, but say this is the X number birds, these birds are at the first position. So these birds can see, or birds can watch the food very first time. They know it. That's why they are changing their position over here. So this is called local based position. Okay, but these birds also, they also know this position, it is not the global based position. Means they, these birds, this position is not the highest position by by which or by where we can get this food. We have to change this. But so they one by one they want to change this position. This is local position. But whenever some birds say these birds can watch, yes, here is some food, then these birds just change this direction, then their flock is, you can see their flock look like this. But whenever these position birds change this direction, and the all birds are coming behind these birds. Say this is number seven birds. These seven number birds are coming first, and all other birds are coming behind it, and it's easily reach to the food. In this way, they are changing their position, and evolutionary method means they, whenever they say they watch that this one number birds is not able to find this food, but seven number birds can able to find this food. So all the birds are following the seven number position, not the one number position. So this is called the global position because it reached to the food, but other birds are not reached to the food. Okay, so this is the methodology behind this swarm optimization, or you can say this is particle swarm optimization. So in statement, you can write down this. In statement, you can write down this because this, I think you should write down this. Otherwise, this statement is not available everywhere. So when birds are flying, birds are flying, they are going or moving, whatever you may say, or changing its position and in a same direction, in a same direction. But when you can see, but when one bird notice a food, it will go to the direction, the direction. Okay. Then number three, then all birds follow the same direction. This concept is borrowed in particle swarm optimization. And next point for this two, each member each member of this swarm learns from its experience and also from other members. For changing the search pattern to locate the food. Okay, so this is the particle swarm optimization basic concept, and now how it is working. So how it's work? First of all, based fitness based fitness of each particle is calculated, then based fitness of swarm, okay, then velocity update and position of each particle. Okay, this is the steps for their working. Okay, now first things is coming to variable is coming. First is p based I. P based I. It is p based means local based. Okay, this is local based. The best solution or the fitness achieved so far by particle I. I means ith particle. Okay, and how we know the best solution? When we compare this previous position, so we kept this column for the vector of the decision vector of the decision making. Okay, and now second is G based. This is the best solution that is fitness achieved so far by any particle in the swarm. Okay, in this way we can define these two based solution. This is p based and g based. Okay, and now position updating. Look, this is position update. What is the formula of position update? So particle I is adjusted as xi t plus 1, means previous was t and t plus 1 equal to xi t plus vi t plus 1, that is 1. Okay, this is update velocity. You can see this is update velocity, and this is the current position. Okay, say in your t1 second you are at the x position. Okay, this is your bars. Okay, but after t2 second, what happens? T2 means t1 plus 1. This is t2 second. The velocity is by this velocity is v1. So what happens? It will reach this position plus velocity, then it will get this position. So this is the position update. You are in, say you are in the x position, you are moving in the 60 kilometer per hour, say 60 kilometer per hour by something car or something bike. So after few seconds, means t1 and t1 plus 1 second, say 10 minutes later, you reached what, or 1 hour, you reach another 60 kilometer, because in 1 hour you are applying 60 kilometer per hour. So you are just, your next position is this x position, x plus 60 kilometers. Okay, so this is your current, this is your latest position or updated position. This way they are changing their positioning. And now velocity of the particle is updated. Velocity of the particle is updated. Particle I is updated as follows: vi, that is t plus 1, equal to omega vi, that is t, means current position, plus c1 r1, that is pi lb, this is local based. Okay, pi lb, and t minus xi, that is t. Okay, plus c2 r2 pgb, global based, that is t xi t. Okay, so you can see there is a three parts. First, this is the one part, this is the two part, second is the three part. So one by one we have to discuss. So what will be my velocity? It will depends on these three factors. The first part, so this is a three vector also. Okay, so I is the ith part. You can, we have to know what are the uh, what are the meaning of this I, omega, C1, R1, C2, R2, etc. Okay, so I is the ith particle. I is the ith particle. Okay, and T is the generation counter. Generation counter. Okay, and this is VI. VI, this is velocity of ith particle. This is velocity. Vi means velocity of this ith particle. It is set randomly. Okay, and now omega is add to the initial position. Okay, and now C1, C2. This is C1 and this is C2. Okay, at the acceleration coefficient, and R1, R2 are random, that is belong to 0 and 1. This is local based. Okay, and PGB is the global based. And XIT is the current position of the particle. Okay, so one by one, if we go for the discussion, you know that is there is a three parts, that is omega VIT, and second part is C1 R1, that is local waste, and minus XIT, and this is third part is C2 R2 global waste and minus XIT. Okay, so first part is first part is that is omega VEI. It is called momentum part. Okay, second part is called cognitive part, and third part is called social part. So look, this is the only velocity is there. Velocity is there, and velocity is added with this omega value. Okay, initial. This is initial. This is one initial potential, or you can say this is the weightage. Say your normal velocity is 10, but if you want to reach very faster, then you apply 20. So 2 is multiplied with this 10 velocity. This 2 is called omega. Okay, this is weightage. So this is a momentum part only. And this position is selecting at the decision part. Look, these two parts are taking decision which direction and how much velocity should be achieved. This is caused by the local p based, and this is a global p based. Say for an example, in a class, in a normal total college, say X college or the X department, this X college for this department, the first student come with this 85% marks. He is satisfied with this 85% mark because he stood first. But if I varying it, total university, there is so many colleges, X college, Y college, Z colleges are there. In here, you can see someone get 85% marks, someone get 97% marks, someone get 95% marks. So whenever you go for global, then your position is not best, but best position is the Y position. And because this college, the student achieves 97% marks. So this is the global variable. But in your local variable, local P best, you can say he got 85% marks. So this is the best position. But this is based for the locally for this X college. But the according under this university there is so many college X Y Z and so many college UV, so many college. Within this, Y college is getting 97% of marks. So this is the best position. This is called global based and this is called local based. X college 85% marks. What this is a local based position and your global based position is 97%. So in this swarm of particle, you can see swarm of particle, it is moving one, two, three, four. If this is last, this is best. But whenever they reach the food, whenever they reach to the food, you can see this these birds reach to this food. So this is the global best position. In this way, eh, we are going to the iteration process, and ultimately we get the fitness factor and fittest position. So if we now another slide, if we go for an vector formula, say this is black vector formula, this is the global based pgb, and this is the local based, say this is the local based is PILB, PILB, and this is our XI at the T, means this is our current position. So this is going on, this is omega V, VI, okay, omega VI. So what happens? After some times, if we add some vector position, you can see this is G, this is PLB, this is GB, PGB. So we just make it at the negative direction. Okay, this is PG, and if we add some vector summation, we add some vector summation. This is omega V. So this is called social, sorry, this is called social equation, and this is a cognizant part, cognitive part. This is the social part, this is cognitive part, and this is momentum part. So three parts are added by this way so that we can reach this position. This is the vector sum. This is the vector sum. So in this way, we can achieve the the fitness factor or the best solution. So if PIBL, look, it will change if position will be changed if xi t plus 1 is less than f of PLB. Okay, PILB remains same otherwise. Means this position is less than the fitness, local fitness, then it will change, it will update. Otherwise it will remain same. Okay. And PGB global waste, it's just belong to say 1 to n factor, it will get only the minimum value of function any p to pn. Okay, so in this way we achieve this particle sum optimization, and this is the very easiest process because no storage function is there. We are just one by one going to adding and then calculating. So guys, if you have any question, you may ask me. There is a algorithm also is there. One by one checking is there. So thank you. I'm stopped here.